Okay, so there's really two types of monopoly graphs that you can expect to see. And whether or not you're looking at the one on the right or the one on the left, it really depends on the source of market power. So in this scenario, the source of market power is often something like patent. So this company might be an inventor that holds the patent on a unique product. And so as a result, for some amount of time, typically 17 years, all other competition is prevented in the marketplace as a way to reward and encourage innovation. And so in this scenario, they have a regular upward sloping marginal cost curve. And so when you do the analysis, you have a downward sloping demand function, you have a marginal revenue curve that's twice as steep. At the intersection of marginal cost and marginal revenue, that's where any firm, no matter what type of firm they are, that's how they decide how much to produce. The difference between a firm facing a lot of competition and this firm is that they can then take that quantity in the marketplace and plug it right into the demand function, and they can charge a higher price than they could charge if they were in perfect competition, if they were not rewarded with that patent. So normally they would get a price of PC, the competitive price at the intersection of marginal cost and demand. Remember, the monopolist, we don't call it a supply curve, we call it a marginal cost curve, because the supply curve says, you tell me a price, I'll tell you how much I'm willing to produce. Remember, the monopolist gets to influence that price by limiting the number of units in the marketplace from QC to QM. And so as a result, you end up seeing less produced under monopoly conditions and sold at a higher price, all the way up to the consumer's willingness to pay. The welfare analysis that falls out then is that consumers would get ABE, this triangle here, if there was competition. Producers would get C and F, this triangle here, if there was competition. However, if you allow for this patent to exist and limit competition as a result, what happens is consumers pay a higher price, so the price they get out to the quantity traded up to the marginal value, that becomes area A, a limited and smaller consumer surplus under this scenario. And then producers get a higher price out to the quantity traded all the way down to their marginal cost, so they get B and C. So that means that E and F, this right here, is all deadweight loss. Now, why is that deadweight loss? Well, in its strictest sense, what's occurring is that these are valuable units who would have been traded in the open markets because the marginal value is greater than the marginal cost, but we're not seeing those units traded because of this push-pull that monopolists have. If they release more products into the marketplace, they can't charge as high of a price. So the revenue reduction from the lower price outweighs the increase in revenue from increased sales for all of these units. So we don't see them choosing to produce these units as a result. And so you get that deadweight loss. Now, as you go on in economics, you'll learn the nuances about how important it is to reward innovation with things like patent rights, because if we don't, perhaps we will get less innovation and then that marketplace might not exist. So go on in economics to find out more about the importance of rewarding innovation and patent law. So the other graph that you might see is this one right here, which is called a natural monopoly. It has a constant marginal cost. This happens when you tend to get very large startup costs because of expensive infrastructure, say, but then the cost to send out each unit is very constant and low. Utility companies tend to be like this. Think about the cost to set up a, electricity production. So the cost to set up that plant is really high, but once the infrastructure is laid, the power lines are created, the cost to send out each watt is fairly low. And so you get this scenario. Again, you would have got at the intersection of marginal cost and demand much more quantity in the marketplace sold at a much lower price. However, because of this push-pull, you end up getting the monopolists choosing to release and produce less units. They then, at the marginal cost, marginal revenue, and then they're going to take that quantity and just plug that right into the demand function. and out will pop the price the monopolist charges. The welfare analysis that falls out then is that under competition, everything that exists in the marketplace would have gone to consumers, A, B, and C. Producers wouldn't have gotten anything. And so if we don't allow utility companies to price with some amount of market power like they're monopolists, we tend to not see firms wanting to invest their inputs into things like this because there's no producer surplus to be had. It's one of the reasons why monopoly pricing or some sort of return for these firms are allowed. And so in this case, consumers would have a limited just to area A. Producers would get the price relevant to producers out to the quantity traded down to the marginal cost. Area B, that's that rectangle or triangle depending on those shapes. And then you would get a deadweight loss of area C. These are valuable units that have a marginal value greater than the marginal cost. We're not seeing those being traded again because the revenue loss from producing those additional units is outweighed by the revenue gain from producing those additional units is outweighed by the revenue loss from the reduced price. And so you get this limited quantity in the marketplace. And so that's the two types of graphs that you might see in the monopoly chapters, one for natural monopolies and one for things like patent rewarded monopolies.